From the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, welcome to the NASA New Horizons mission Countdown to Pluto. I'm Mike Buckley from APL Communications and Public Affairs, bringing you the first of these weekly updates from Pluto's doorstep as we count down to New Horizons' historic flight through the Pluto system on July 14th. It took more than 9 years and a voyage of 3 billion miles to get here. The mission team has been looking forward to this for a long time, and we invite you to join us on this adventure.
Ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
We're 34 days from the Pluto flyby. The spacecraft is traveling at about 750,000 miles a day, now just about 26 million miles from Pluto. New Horizons is a key part of NASA's exploration of our solar system. Now, joining me to talk about that is Jimmy Lee, NASA's New Frontiers Program Mission Manager. Jimmy, welcome.
Thanks, glad to be here.
First, start by telling us where New Horizons fits into NASA's exploration of the solar system.
Sure, Mike. New Horizons will provide us a completion of our preliminary exploration of our solar system, the classical planets. It'll provide us our first up-close and personal look at Pluto and its moons. It's very important from a NASA perspective. It's one of a number of missions in our portfolio that will provide for exploration of our solar system and beyond.
New Horizons is actually the first of this class of missions, New Frontiers program. Tell us a little bit about New Horizons in that program and where New Horizons fits into New Frontiers.
Well, New Horizons was judged to be the highest science priority at the time, is the first of the New Frontiers class of missions with the study of Pluto and the Kuiper Belt will allow us to gain an understanding of that region of our solar system and open the door for future exploration.
Now, with that New Frontiers line too, you're responsible for a pretty interesting line of missions, that go to some extreme places in here. What are we waiting for to see from New Horizons, once it gets to Pluto?
Well, it's really the exciting part about it is what we don't know. I mean, with exploration and discovery, you don't know what awaits us out there.
Thanks, Jimmy. Alan Stern is the New Horizons principal investigator. New Horizons is the first Outer Planets mission led by a principal investigator who's charged with managing the entire mission, from developing a concept and assembling a team to building a spacecraft and delivering new science data. Alan, thank you for joining us.
Thank you.
Before we start getting into mission updates, tell us first about the New Horizons mission.
Well, New Horizons is the first mission to explore the Pluto system. It's a flyby like all of the other first missions to the closer planets, but it's a 21st century spacecraft, the fastest ever launch, going the farthest any spacecraft ever has to reach its primary target, and armed with a very sophisticated payload of 7 very high-tech, very powerful scientific instruments so that we can write the textbook on what the Pluto system is all about and how it came to be.
Yeah, like a lot to learn in this case. New Horizons is a mission of firsts.
There are a lot of firsts on this mission. Obviously, it's the first mission to the Pluto system. It's also the first mission to what we call the third zone of the solar system, the Kuiper Belt. It's the first mission in NASA's New Frontiers program of PI-led missions, and it just happens to be the first PI-led mission ever to the outer planets. So there are a lot of firsts in New Horizons. There's also one last, which I think is very important to the mission, and that is that we at Pluto are completing what was begun in the 1960s by NASA with the first missions to planets Venus and Mars. And across that 50-year period, the United States has explored all the planets, and we're kind of running the anchor leg with Pluto to finish the relay.
In fact, I could even go back farther. It would seem like this mission almost started in 1930, when Clyde Tombaugh discovered what we thought was just this oddball planet on the edge of the solar system. But as it turned out, it was actually the first of a whole new class of worlds that New Horizons is traveling to, in a place that we're just now beginning to learn about.
Right. In 1930, when Tombaugh at Lowell Observatory discovered Pluto, he had no idea that he'd actually uncovered the biggest structure in the solar system, the Kuiper Belt. The third zone, as we call it. Sometimes we call it the twilight zone because the lighting levels are so low. And this region of the solar system wasn't really anticipated. In fact, across the whole of the middle of the 20th century, out into the late 20th century, we just thought Pluto was an oddball. Didn't fit the pattern of being one of the inner rocky planets, the terrestrials. Didn't fit with the giant planets at all. It was just off there on its own. And then, beginning in the 90s, planetary scientists began to discover small objects, comets, and the building blocks of small planets that orbit in the Kuiper Belt region. It's teeming with these small objects. Pluto's the biggest and brightest by a long way, but eventually, as more and more data was taken on the Kuiper Belt, it was discovered that the Kuiper Belt also contains a handful of other small planets, other Plutos, even though they're different compositions, different numbers of moons. Some have atmospheres, some do not. But this is Pluto's cohort. This is Pluto's family, and it's the third class of planet in the solar system, the small ice dwarfs.
And our first look at one of these objects is New Horizons. So tell us about the spacecraft. What was put together to get that data and get that first look?
Right. We built a really high-tech, very small spacecraft about the size of a baby grand piano. Even with the fuel on board, it weighs less than 1,000 pounds. The spacecraft has tremendous capability for conducting a reconnaissance flyby. Fast turns, very large solid-state memories for storing data, fast bus speeds on the spacecraft so we can take data from up to 5 instruments at once, many other capabilities as well, and highly miniaturized so that we could be very light and get a very fast launch as a result of that. On board the spacecraft, the real business end of the mission is the scientific payload. We have 7 scientific instruments on board. We have 9 cameras for mapping. We have 2 spectrometers for atmospheric and surface composition. We have the capability to do thermal mapping on board, to measure dust particles, dust impact rates in the solar system and also at Pluto, to sample the material coming off Pluto's atmosphere, determine its density and its composition. So there's a very powerful suite of instruments, and because we miniaturized them, it's amazing. All 7 combined weigh less than just the camera on the Cassini-Saturn orbiter. And combined, when we turn them all on, we're talking 28 watts. That's like a night light to run all these high-tech instruments in their computers.
So what are these instruments and what are they going to learn? What are they going to gather in the Pluto system? What are the goals that we're going to bring back from Pluto when we fly through that system?
Mike, we're going to write the textbook. We know very little about the Pluto system now. It's really a mission of raw exploration, flying into the unknown to see what's there. So we're going to produce maps of Pluto's surface in black and white and in color, in medium resolution and high resolution. The same for Pluto's big moon, Charon. We're also going to image all of the small moons. We're going to search for new moons. We're going to search for rings. We're going to determine the atmospheric composition, its structure with altitude. We're going to determine the atmospheric escape rate, whether the atmosphere has an ionosphere. And then we're going to make composition maps so that at every pixel we'll have a spectrum on Pluto, 64,000 locations. And we're going to do similar mapping of the big moon Charon and lower resolution mapping of the smaller moons. And that's not the full list, but it gives you an idea for the range and variety of data sets. For example, I didn't tell you anything about stereo mapping, but that's something else we're going to do that's going to give us the ability to reconstruct the topography on Pluto's surface in 3D.
I mean, so we're already getting the idea that this isn't just a weekend at Pluto, this idea, right? The flyby itself is July 14th, but it's a 6-month encounter, beginning back in January. What have we learned so far? Are we learning things about Pluto now that we didn't know before New Horizons started speeding closer to the Pluto system?
Well, that's another great question. We started in January with environmental monitoring, the region of space where Pluto orbits. And we're using the plasma instruments on board to study the heliospheric environment. We're now using the ALICE ultraviolet spectrometer to also study the charged particle populations out there. The dust instrument is on, and it's measuring the dust impact rates in the Kuiper Belt. And as we started to draw closer in April, we started to image the system with LORRI, which is our long-range reconnaissance imager. LORRI's already detected what we think is a polar cap on Pluto. Other very large surface markings, some are bright, some are very dark. We don't really understand why Pluto should be so contrasty, but I've never seen an object in my career in planetary science that looks this interesting at low resolution. And I think it really promises over the next few weeks to get to be a better and better ride as we start to uncover what's really there.
I want to talk about that ride. We mentioned earlier, just in your introduction, the role of the principal investigator. But as we're getting close to Pluto, we're on Pluto's doorstep. To tell us a little bit about what it's like to be leading this team. This is a mission you've worked on for a long time. To be this close, just take us through what you're thinking and guiding this team to that ultimate.
Well, New Horizons is a small team compared to some missions. When we were building it, there were 2,500 Americans that were involved in building the spacecraft, the payload, the ground system, and the rocket, of course, the launch vehicle. But in flight, it's been a very small team, about 50 people until recently. We've staffed up for the encounter. Mm-hmm. But we've got experts in guidance, in spacecraft systems, in the science, mission operations, mission planning, all the disciplines that you need. And this is one charged up team. They know that they're getting to do something very special because nothing like this has happened before since the 1980s. That's the last time, Voyager had a flyby at Neptune. And nothing like this is planned to happen again, ever, by any space agency. And so the team is not only psyched up, they know that they're doing something very, very important that we only get one shot at. And leading an effort like that is it's humbling, it's a privilege, and it's exhilarating at the same time because we're going to turn a point of light into a planet and its moons overnight in the next month.
Thanks, Alan. We've heard from the principal investigator. Now it's time for a mission operations update. Each week, we'll provide updates on spacecraft operations and mission science. Now, to give us the operations update is Mark Holdridge, the New Horizons Encounter Mission Manager. Mark, you've had roles on many missions. Tell us a little bit about your role on New Horizons.
Well, as Encounter Mission Manager, my responsibility is primarily for planning and execution of the flyby. As you know, there's a tightly choreographed sequence of events that take place around the time of the flyby, and a very diverse team of navigators, scientists, engineers, and operations personnel. And so we have to all work together to optimize the timeline and reduce risk and come up with the plan, if you will, that we then execute. So I've been spending the past several years running a number of different meetings and having technical discussions with the team members to try to refine the timeline and come up with a good plan for how to do all the operations.
So you mentioned that team. Take us through what the team has been going through the last couple of weeks.
Yeah, so we've really turned the corner on the operation in the past week. We're what I would say on final approach. We've transitioned from spin mode, where we were playing back the recorder data to make room for the data that we're going to be recording in the weeks ahead. We've begun the final OpNav imaging campaign and also resumed science operations. And those will continue now seamlessly through the flyby. So we don't have any more periods downtime where we're spinning the spacecraft. Everything is up and running now, as it will be throughout the whole flyby.
You mentioned OpNav, navigation, right? So tell us how you're guiding New Horizons toward the Pluto system.
Well, we start off with what we call an a priori estimate for where Pluto is, and we revise that estimate with Earth-based observations as well as the spacecraft's trajectory, and then we difference those two to determine, what maneuvers to do to get to Pluto. Starting the beginning of this year, though, we really transitioned to a relative body type navigation using optical navigation, using the spacecraft's onboard camera and imaging Pluto directly and figuring out from the spacecraft's perspective where it's headed, relative to Pluto. And as we get closer and closer to Pluto and it gets bigger and bigger in the frame, we come up with more refined estimates, and we continue to tweak those estimates on approach and determine when or if we need to correct the spacecraft trajectory.
Now, we haven't done many of those maneuvers, right? I get an indication that the spacecraft has generally been on track.
Right. Yeah, we had one maneuver in March, and we have a number of placeholders in the weeks ahead in case we need to do it to tweak the trajectory or as a hazard avoidance type maneuver. But we're really hopeful that we'll have one, maybe two more maneuvers. So we want to be very careful about when we do the maneuver so that we don't have to do another one after it. So we're trying to economize on the number of maneuvers.
Okay. And either way, just to get to this point, it's a pretty precise operation during the flyby of Pluto.
Yes, I mean, we're trying to hit a very small box, relatively speaking. It's 60 by 90 miles, and we're going 30,000 miles per hour, and we're trying to hit that box within a plus or minus 100 seconds. And that's really necessary. We want to do that to ensure that we achieve the science objectives of the mission.
So what's next for the team over the next couple of weeks?
Well, we're going to continue to monitor the trajectory, again, using the optical navigation as well as radiometric tracking from the Deep Space Network, and it's going to continue to tweak, the trajectory if we deem it's necessary. And of course, science is ongoing. We're continuing to image Pluto as it's getting bigger and bigger and starting to show some of its features, and all this is happening in parallel.
All right. Well, thanks, Mark. Now, speaking of science, now let's get a science update. Providing our science update this week is Hal Weaver, the New Horizons project scientist. Now, one thing I always found interesting about your job as project scientist is you're sort of the go-between, a dual role between the spacecraft team and the science team.
Yeah, that's right, Mike. I mean, we have come from two very different cultures. The engineers, they really are in charge of getting what we need, but we have to let them know what we need. The scientific objectives of the mission is specified by the science team, but there are a lot of details that have to be worked out. And I'm that interface, that liaison between the two groups.
All right, so the flyby is July 14th. We heard earlier about some of the overall science goals of the mission. But this is a 6-month encounter, and we're already getting some results.
Oh, absolutely. We've, in fact, already taken images with higher resolution than what's ever been done before, and it just gets better every day, every week. We come in, and we're squeezing as much information as we possibly can out of these images and seeing details like we've never seen before, and it's just getting better and better.
All right, so what are we learning about Pluto so far?
Yeah, so far, actually, what we've learned from the previous Hubble observations about dark spots and bright spots on Pluto seems to be pretty much borne out by the New Horizons images. But now, what we're really going to be trying to do as we fly by Pluto is learn why. Why are we having, what's causing these bright and dark spots on Pluto? Exactly what is it?
Now, you're taking different types of images, too. There's some for the surface, but there are also some that are looking deeper into the Pluto system.
Yeah, that's right. We basically have two big objectives in mind. One is to just get better resolution on Pluto and Charon. But in addition, we're also taking very deep, long exposure photographs of the system, images of the system, in order to look for new satellites and dust particles that may pose a hazard to the New Horizons spacecraft as it flies by. Now, we haven't seen anything yet, but we're like, up in the crow's nest on the spacecraft, coming in and looking for anything that might harm us.
Okay, so that's what we have so far. What's next on the science plan?
So, just better and better, basically, as we come closer and closer to Pluto, getting more resolution on Pluto and Charon, going deeper and deeper. We're already well below what has been done from Earth-based observations in terms of looking for new satellites and dust in the system.
So anything you see from this point on would be something new.
All of this is new. From now on, it's new, and it's just getting better and better.
Yeah. Thanks, Hal. So that's the latest from NASA's New Horizons mission on Pluto's doorstep. 34 days and 26 million miles to go until the Pluto flyby. The countdown continues. I'm Mike Buckley from the Johns Hopkins Applied Physics Laboratory, and we'll see you next week.